Hello, it's Davin, and today I'll be continuing to talk about atmospheric science. This is video number 1 after the introduction video. So we talked about the event description in the introduction video, and right now we're on the first of the 4 main topics that we'll cover in atmospheric science, which is atmospheric structure and composition. And we'll be talking about this topic for about 3 more videos, including this one. So we'll talk about greenhouse gases first. A greenhouse gas is any gaseous compound in the atmosphere capable of absorbing infrared radiation. And when greenhouse gases absorb infrared radiation, they trap and hold heat in the atmosphere, which increases the amount of heat in the atmosphere, and which is responsible for the greenhouse effect, which leads to global warming. So a quick description of the greenhouse effect is in the picture on the left. Most of the heat is absorbed by greenhouse gases and reflected in all directions, and this warms the Earth. So the greenhouse effect occurs when the sun bombards the Earth with radiation, which strikes the Earth's atmosphere in the form of visible light, ultraviolet light, infrared radiation. And 70% of this radiation is absorbed by the oceans, the land, and the atmosphere. However, as they absorb this radiation, the oceans, the land, and the atmosphere heat up, and they release heat in the form of infrared thermal radiation, which passes out of the atmosphere in space, but this actually helps keep the Earth's atmosphere at around 59 degrees Fahrenheit. However, weaker infrared radiation has difficulty passing through the atmosphere, so this leads to global warming. So in the image to the right, we see some of the activities that occur that are part of the greenhouse effect. So most radiation is absorbed by the Earth's surface and warms the surface. Some of the solar radiation is reflected by the Earth and the atmosphere. And we see here that some of the infrared radiation passes through the atmosphere. Some of it is absorbed and emitted in all directions by greenhouse gas molecules. And this actually warms the Earth's surface and the lower atmosphere since the greenhouse gases reflect the radiation in all directions, as we can see in the image earlier. And some infrared radiation is emitted by the Earth's surface. So here we have an image about how greenhouse gases warm our planet. It defines the global warming potential, which is a measure of how much heat each gas traps in the atmosphere relative to carbon dioxide. And since we're comparing it to carbon dioxide, the GWP of carbon dioxide is 1. And we see that methane, nitrous oxide, and fluorinated gases have a larger impact on the Earth's atmosphere than carbon dioxide. But then if we look at the pie chart to the right, how much each human-caused greenhouse gas contributes to total emissions around the globe, we see that carbon dioxide has a significant impact and contributes a lot to total emissions around the globe. So even though methane, nitrous oxide, and fluorinated gases have a greater global warming potential than carbon dioxide, the percentage of carbon dioxide of how much each human-caused greenhouse gas contributes to total emissions around the globe means that carbon dioxide plays a significant role in global warming. So some primary greenhouse gases include water vapor, carbon dioxide, methane, and nitrous oxide, and these are all natural. But after the Industrial Revolution, the concentration of all of these compounds, with the exception of water vapor, increased in the atmosphere significantly. Another primary greenhouse gas is chlorofluorocarbons, which are man-made. So note about water vapor, it's the most abundant and dominant greenhouse gas in the atmosphere, but its concentration really depends on weather-related factors like temperature, so we'll focus on the other greenhouse gases. In the table to the right, we'll see that carbon dioxide, its concentration has increased since industrialization from 280 to 408 parts per million by volume. And even though methane, nitrous oxide, and even sulfur hexafluoride have a greater global warming potential than carbon dioxide, the concentration of carbon dioxide in the atmosphere compared to these other compounds is much greater, and that's why a lot of the discourse surrounding global warming is focused on carbon dioxide and carbon dioxide emissions from the burning of fossil fuels. Next, we'll talk about ozone. So there's actually 2 types of ozone, as we can see in the picture to the right. So 90% of ozone is in the stratosphere, and this is good ozone, since ozone in the stratosphere absorbs radiation from the sun. 10% of ozone is in the troposphere, and this ozone is a pollutant and hazardous to our health. We can see in the image that ground level ozone is a greenhouse gas and a major component of smog. In the stratosphere, concentration of ozone is less than 10 parts per million, while in the troposphere, the concentration of ozone is 10 to 30 parts per billion. And this ozone in the troposphere comes from chemical reactions between sunlight and pollutants emitted by motor vehicles and industrial processes. But we see that this ozone from the troposphere has a significant impact on the environment and also human health. Breathing in oxygen causes damage to the lung tissue and narrows the passages that let air in and out of your lungs. Also, items such as rubber and nylon break down in the presence of tropospheric ozone. And in the right, we can see an image of a city impacted by tropospheric ozone. Next, we'll talk about fluorinated gases. They're used as substitutes for ozone depleting substances like chlorofluorocarbons. After scientists saw the link between the depletion of the ozone layer and chlorofluorocarbons, they've been using fluorinated gases more. But fluorinated gases include the most potent and longest lasting greenhouse gases emitted by human activities. So fluorinated gases will also have a negative impact on the environment. And we can see in the chart that 92% of fluorinated gas emissions came from their use in the substitution of ozone depleting substances. Next, we'll talk about aerosols. They're minute particles suspended in the atmosphere. Natural aerosols include fog, mist, and dust. Most aerosols are classified based on shape, size, and chemical composition. Different types of aerosols often clump together though to form complex mixtures, so sometimes we cannot identify what type of aerosols are present because of how clumped together these aerosols are. First type of aerosols we'll talk about is black carbon, which is formed by the incomplete combustion of fossil fuels, wood, and other fuels. Household cooking and heating account for 58% of global black carbon emissions. And they're an aerosol because the combustion of fossil fuels would usually result in carbon dioxide. But since we're dealing with incomplete combustion, we don't have carbon dioxide, and we actually create a complex mixture of particulate matter called soot. And black carbon has a warming impact on the climate 460 to 1,500 times that of carbon dioxide. So it's much more dangerous than carbon dioxide to the environment. Next, we'll talk about sulfate and nitrate aerosols. Sulfate aerosols are created by the burning of coal and oil. Nitrate aerosols are produced from the reaction of gas phase nitrate, nitric acid, and ammonia. So they're both created from chemical reactions. Human-made sulfate aerosols have been outweighing the naturally produced sulfate aerosols in the past few years. And the concentration of sulfate aerosols is highest in industrial areas in the northern hemisphere. Sulfate aerosols absorb no light but reflect it, and they often survive for 3 to 5 days. And they often enter clouds, which causes the number of cloud particles in these clouds to increase, but also makes these cloud droplets smaller. And this makes the clouds reflect more sunlight. Next, we'll talk about particulate matter. In the image to the right, we see how particulate matter enters the body. It enters through the nose and mouth when we breathe. Larger molecules are mostly eliminated by the body, which includes PM10, inhalable particles 10 micrometers and smaller. But smaller particles like PM2.5 continue to the lungs, and it can have serious health consequences for the lungs and the heart. Particulate matter is a mixture of solid particles and liquid droplets found in the air, and it's the main cause of haze in parts of the United States. Smaller particles can have an adverse impact on human health because it can easily enter the body, and the body cannot eliminate it since it's very small. So this video was very quick, and we won't have review questions since we'll continue the theme of atmospheric gases and aerosols and their impact on the climate. In the next video, we'll talk about the remaining types of aerosols that we didn't discuss in this video, including organic aerosols. And then we'll start the subtopic of atmospheric circulation and climate, including the ITCZ and Hadley cells.